Welcome to FrontEndSystemsLab. This is a channel where we explore what's really going on under the hood of modern web dev. Today we are going to delve into the world of deploying autonomous UI agents that rewrite their own source code. For decades, software interfaces have operated within a fundamentally static model. Developers design applications, deploy them to production, collect analytics, and eventually return to refactor the system manually. Even with the rise of modern AI-assisted coding tools, the core development cycle has remained largely unchanged. Human engineers still identify the problems, decide which architectural patterns need modification, and ultimately approve every significant rewrite. The process has become faster, but it has not become autonomous. That model is now beginning to change. A new frontier is emerging at the intersection of browser telemetry, large language models, and autonomous agent systems. This transition moves beyond simple prompt engineering and enters the realm of self-evolving software. Instead of functioning as fixed collections of components, future applications may become adaptive computational systems capable of monitoring their own behavior, analyzing performance patterns, and restructuring their internal architecture in real time. Modern web applications already generate enormous amounts of behavioral data. Every interaction inside the browser produces measurable signals. Cursor movement, scroll velocity, click hesitation, render latency, GPU utilization, memory pressure, navigation abandonment, and frame pacing all reveal how users experience an interface. Traditionally, this information is sent to dashboards where developers review analytics after the fact. Engineers then decide what changes should be made and manually push updates through pull requests and deployment pipelines. That delay creates a bottleneck between observation and optimization. Autonomous interface systems remove that bottleneck entirely by feeding runtime telemetry directly into LLM-driven reasoning pipelines. Instead of simply reporting performance issues, the application itself begins interpreting behavioral patterns as active feedback. The interface observes user interaction, identifies friction points, and initiates architectural corrections automatically. The result is a continuous feedback loop where software evolves dynamically in response to real-world usage. This fundamentally changes the meaning of front-end optimization. A React component suffering from excessive render cycles could rewrite its internal state management automatically. A bloated component hierarchy could flatten itself in response to performance degradation on lower-powered devices. Animation systems causing GPU instability could reorganize their rendering logic dynamically. Unused hooks, redundant dependencies, and inefficient hydration strategies could all be removed without direct human intervention. The source code itself becomes fluid rather than fixed. At that point, the interface no longer behaves like a static product. It behaves more like a living computational system. This shift represents the transition from AI-assisted development to agentic software evolution. Most current discussions surrounding AI coding systems focus primarily on copilots, autocomplete engines, or prompt-based scaffolding tools. While those technologies are important, they only represent the earliest phase of a much larger transformation. The true breakthrough occurs when software gains the capacity to observe itself, reason about its own architecture, and recursively improve its internal structure over time. The modern web ecosystem has already laid much of the groundwork required for this transition. React server components introduced new forms of rendering orchestration. Streaming architectures changed how interfaces deliver data and hydrate complex views. Compiler-assisted optimization systems continue reducing runtime overhead through increasingly sophisticated analysis pipelines. Type-safe AST transformations now allow precise structural modification of source code. GPU-aware scheduling systems improve render prioritization under varying hardware constraints. These technologies are converging toward the same destination: self-optimizing software ecosystems. The missing layer is autonomous orchestration. Large language models provide that layer by introducing a reasoning engine capable of understanding abstractions, interpreting system behavior, analyzing architecture, and generating adaptive solutions dynamically. When combined with live telemetry pipelines, these systems create the possibility of interfaces that continuously evolve in response to user interaction patterns. The implications extend far beyond front-end development alone. Enterprise software platforms could reorganize workflows automatically based on operational efficiency metrics. SaaS dashboards could restructure layouts dynamically according to user navigation behavior. Educational systems could modify interface complexity in response to cognitive load analysis. Video game engines could adapt rendering pipelines and interaction systems according to player behavior and hardware limitations. Even operating systems may eventually evolve into adaptive environments that continuously restructure themselves around human interaction patterns. As software becomes increasingly autonomous, the role of the developer also begins to change. Engineers may spend less time implementing repetitive optimizations manually and more time designing high-level constraints, safety systems, and evolutionary objectives. Development shifts away from directly constructing every architectural detail and towards supervising intelligent systems capable of recursive self-improvement. That transition introduces significant challenges. How much autonomy should software possess? What safeguards prevent destructive mutations inside self-modifying systems? How can security and stability be maintained when applications are capable of rewriting their own execution pathways? How do organizations audit continuously evolving architectures that no longer remain structurally fixed? These questions will likely define the next era of software engineering research. The companies that solve these problems first may ultimately control the future of computing infrastructure. Competitive advantage may no longer come solely from building the best software manually. Instead, it may come from creating systems capable of improving themselves faster than human development teams ever could. That is the true significance of autonomous agents integrated directly into modern interface architectures. We are not simply automating coding workflows. Thanks for watching Front-End Systems Lab. Please subscribe for more under the hood content. We are beginning to automate software evolution itself.